Alright everyone, we're going to start with our first unit. Our first unit's on trigonometry, and we're going to be looking at solving triangles. But before we get into the new material, we're going to spend a day or so looking at old trig that you would have learned in grade 10. So we want to make sure everybody's fresh and kind of remembers how that works, and then we'll move on to the newer stuff in a bit. So to start with, let's take a look at a right angle triangle. So you can see on here we've got a right angle triangle. Few things about how we label them. So you usually label the triangle ABC, but you could use whatever letters you want. Sometimes they won't be labeled at all. It doesn't really matter. But we'll stick with this one. So the thing to remember is if we have angle A, so you can see here we've got angle A in the bottom left corner here, so angle A. And what we want to do, remember then from that angle A, all the sides are going to be relative to that position. So the opposite of A is the one straight across. So that'll be our opposite side, and we would label it with a small a. And the same thing would happen with angle B. So angle B is the top one here, and the side opposite to it is letter B. So how come I have it labeled as adjacent? Well, all of these three labels are based on what we would see from angle A. So using angle A, the red one, the opposite side is little a, little b is opposite to angle B, but so that one's the opposite, but it is adjacent to A. So we got to be careful when we're doing these triangles because the opposite and adjacent sort of depend on which angle you're looking at. And the last one is the hypotenuse, and the hypotenuse is always the one across from our 90-degree angle. So the hypotenuse will never change. It'll always be across from our 90-degree angle, and it's also the longest slanted side of our triangle. So that one always stays the same. The ones you got to be careful of are the adjacent and the opposite. So before we move on, let's just make sure we're clear on that. So if I said now we want to worry about angle B, so if we were talking about angle B in the picture, our opposite would be this one, so that's no longer the adjacent, that would be our opposite. And then side A, the one beside B, would be our adjacent. So opposite is easy to remember, just the one straight across. Adjacent is the one that's right beside it, that's touching it on the side. Okay, and then remember hypotenuse never changes. So those are a couple of key things to remember when you're dealing with triangles, because you have to be able to label the sides correctly to be able to use the right formula and calculate the answer. So let's do a couple of examples to remember how do we do this on our calculator and stuff. So the first few I've got on here are dealing with the tangent. So if you might remember from last year when you're doing trigonometry, there's three. There's a tangent, a sine, and a cosine. And it just depends on how the triangle's set up to be able to figure out which one to use. So let's start with this first one, and that'll help us kind of remember how this works. So if we look at question 5a that's on here, it says we want to find side x. So when you're doing this, you always want to look at the angle you're given. So in this case, 40 degrees is our angle that we're dealing with. So our side opposite to the 40 degrees will be our side x that we're looking for. And then the adjacent, the one beside it, will be our 5.4 in this case. Okay, so in this case we have opposite and adjacent are the two sides we're dealing with, and in our tangent formula, opposite and adjacent are the two sides we want to use the tangent. If it was opposite and hypotenuse, we'd use sine. If it was adjacent and hypotenuse, we'd use cosine. So it just depends on which two of the three sides of the triangle you're given, and then that'll determine which formula. So in this case, opposite and adjacent, we want to use tangent. So we just plug everything into our formula. So you'd have tangent of 40. So our angle is 40 degrees. That's just the symbol. This symbol here is quite often what we use for angles. You can see down in this example down here, that's the theta symbol. But it could be anything. It could be A, it could be B, or doesn't really matter. Okay, so we have tangent of the 40 degrees, and that's going to equal our opposite side. So in this case, our opposite side was x, and our adjacent side is the 5.4. And that's it. So we've picked the right formula. We've got our opposite and adjacent plugged in correctly. Now the last step is how do we calculate these on our calculator again. So to remember, when you're doing these, you want to cross multiply. You want to be able to crisscross to solve these things for x. So remember, anytime we have a fraction, we can actually write that as over 1. So we'd have tan 40 over 1 equals x over 5.4. So now to solve it, we cross multiply the two that we know the answers for, so the tan 40 and the 5.4 we know, and then we're going to divide by the one that's with the x. So in this case we'd have x times 1, which is x. That's going to equal 5.4 times tan 40. Okay, and you can write it like that. We could put a dot in there to show times. You could use brackets. It doesn't really matter how you write it. Basically, you just want to remember you go tan 40 times 5.4, and in this case we divide by 1 because it's 1 times x, but we don't really need to worry about the 1. And that's it. So that'll give us the right answer for this question. So what you want to do is on your calculator, you need a scientific calculator. And if you don't have one, you can put one on your phone or whatever, but you're going to need one, so get it soon. And to do this calculation, basically what you just want to remember is check your mode on your calculator, make sure you're in degree mode, otherwise it's not going to work. And then just go tan 40 times 5.4 or 5.4 times tan 40, it doesn't matter which order you put it in. Plug that in on your calculator and you should get 4.5311 and so on. And usually for trigonometry, if we just do one decimal place for the sides, that's good enough. So in this case 5.4 was our one side. If we do our answer as 1 decimal 4.5, that'll be in centimeters, and we're done. So for that first question, there's the solution. Alright, let's do letter B because it's similar. So when we look at letter B, let me just erase this so we have some room. So letter B, you want to start the same way again. You want to look at the triangle, try to figure out which formula you need to use. So in this case, start with our angle 61. So we're going to have tangent of 61. And it's going to be the opposite. So the opposite in this case is 14.2. And we're going to divide by the adjacent, which in this case is x. Okay. So for any triangle you're going to get, you want to start with the angle, figure out whether you have the opposite, adjacent, and hypotenuse sides. Pick your formula. So in this case, because it's opposite and adjacent, we pick tangent, plug your numbers in the right spot for the formula, and then you're ready to cross multiply. So in this case now, when we cross multiply it, we have tan 61 times x, so that'll be x times tan 61 will equal 1 times 14.2. Okay, so then we're not quite ready to solve this on our calculator yet. We want x by itself, so then we're going to have to divide both sides by tan 61. So your calculation should be 14.2 divided by tan 61. And that's it. So then plug that on your calculator. Go 14.2 divided by tan 61. And it should give you an answer of 7.87. So let's round it to 7.9. Okay. When you're doing these questions, it's a good idea to go back to the original once you have your answer and see if it actually makes sense. So in this triangle we had a side of 14.2, so does that make sense that this side would be 7.9? Sure, that seems reasonable. If you're doing a calculation and you got an answer like 700 there, then it doesn't really make sense. If one side's 14, it doesn't make sense the other side to be 700. Or same if you got an answer like 0.07, that wouldn't make sense. Okay, so use a little bit of logic when you're doing this just to make sure you didn't mess up anywhere. Okay, the two on the bottom are still tangent, because if you look at the angle, let's just look at one of these here. So if I say we're going to look at that angle theta, we have the opposite side of 6, and we have an adjacent side of 8.2. So we're still dealing with tangent. The only thing that's different now is instead of looking for a side, we're actually trying to solve for the angle. Okay, the good news is it doesn't matter what you're looking for, you'd still solve it all exactly the same way. So let's plug it into the formula again. So in this case we'll have tan theta will be opposite, which is 6, and over adjacent, which is 8.2. Okay, so this case we're looking for an angle, so we don't need to do cross multiplying or anything, we just need to solve it for theta. So really what we got to do is we just got to get rid of the tan part, and on your calculator that's when you want to go shift or second tan. So you want to do the tan, and it has a little -1 on the top of it to remember that you're doing the opposite, and then 6 divided by 8.2. So we just sort of do the reverse of the tangent, so second tan 6 divided by 8.2. You might need to put brackets. I'm just going to redo mine because I think I forgot brackets. So I went second tan brackets 6 divided by 8.2. And that gives me an angle of 36.19. And usually angles, because 1 degree is pretty small, if we just round them off to the nearest degree, that's good enough. Okay, so in this case our angle would be 36 degrees. Okay, for letter B, I won't bother doing this one on here, but you would do it the same way. You'd have tan of the angle would be opposite. So our angle opposite would be 24, adjacent would be 15, so we would just go second tan, 24 divided by 15, and put that on your calculator and you get 57.99, so we could round that off to 58 degrees. So angle A in this case is 58 degrees. And that's it. So that's a couple good examples showing the different tangents. So the red one up in the top, 5A, we had opposite over adjacent, and when we cross multiplied we did some multiplying. Letter B, if you remember, when we cross multiplied we had to divide because the x was the adjacent side. And then number 6, we're looking for the angle. So any question where you're looking for opposite, adjacent, or the angle, you'll always use tangent. So these examples will cover every possible question you could get. I could give you a million more of these. They'll all be exactly the same, just the numbers change. Okay, so now let's spend a bit of time looking at the other two. So if you look at question 4, let's do the same thing again. So let's start with our angle. So our angle is 32 degrees. We want to figure out which side's which, so this would be our opposite. So in this case, x is our opposite side. The adjacent side is down here, but there's nothing there, so that doesn't help us. So then we have to go the other way. So in this case, we have 11.5 being our hypotenuse. So in this case now we're dealing with a triangle that has the opposite and hypotenuse. So we can't use tangent. Tangent, remember, was only for opposite and adjacent. So this is where we're going to use sine. So the sine of an angle is opposite over hypotenuse. Okay, so anytime we get a scenario like that, we're going to use sine. The good news is everything is exactly the same as what we just did. We just used the sine button instead of the tan button. So let's do this one. So if we plug it in, we'd have sine of 32 will equal the opposite, which is x, divided by the hypotenuse, which is 11.5, and then we cross multiply. So you can see with all these questions, we're doing the same thing. You're going to label your triangle, figure out which sides are which. Then you've got to decide between tan, sine, and cosine. And once you do that, then you cross multiply and solve your question. So if we cross multiply this one, we'll have x times 1, which is x, sine 32 times 11.5. So we'll multiply those on our calculator. And we're done. So x will equal sine 32 times 11.5 gives me 6.09, so let's round that off to 6.1. Okay, so that's it. So you can see the math is exactly the same, we're just picking sine instead of tangent. So let's look at letter B to see how it's different. So letter B, we'll do the exact same thing again. We'll start at angle 50. So starting with the 50, our opposite this time we don't know, so that's not going to work. So we're going to use the adjacent side, right? The x is our adjacent side, and the 9 is across from our 90-degree angle, so that'll be our hypotenuse. So you can see we've got adjacent and hypotenuse, so tangent doesn't work, sine isn't going to work, so this is where we're going to use cosine. So our formula for cosine is adjacent over hypotenuse. Okay, so cosine is adjacent over hypotenuse. That's our third formula that we're going to use. So letter B, we would set it up exactly the same way, except we would write it as cosine of 50 instead of sine or tangent. Adjacent is x, hypotenuse is 9. We're going to cross multiply, so we'll get x times 1 equals cos 50 times 9. And you can do that on your calculator, and your answer is 5.8 if we round it off. Okay, so that's it. Those two examples show us just two different triangles where we'd use sine and cosine instead of tangent. But you can see the process is the same for every question. We just determine whether we're going to use sine, cos, or tan, and then you solve it by cross multiplying. So it's the same thing over and over. So what happens with trigonometry is once you understand it, most people find it really easy because they're the same kind of questions over and over. You just have to determine which formula to pick, and then make sure you cross multiply it properly to get them. So let's just look at these last couple quickly. So this letter C, same thing. Let's start with our angle. So we've got opposite 6.4, and we got our hypotenuse as x. So then we would do up our formula as sine, right? It's opposite over hypotenuse. So we'd have sine 23 equals 6.4 over x. Cross multiply, this is one of those weird ones because their x is on the bottom, so when we cross multiply we'd actually have x times sine 23 equals 6.4 times 1. I want to show you a little trick here. What comes in handy is when you see it like this, you can always, because we're cross multiplying, we can actually just flip-flop those two. So you could rewrite the question as x on the top on that side, and we can just move the sine 23 on the bottom on this side. We don't really need to put the 1 in because divided by 1 doesn't do anything anyway. Okay, so that's an easier way to do these questions. Just sort of flip-flop them, and then you're good to go with your calculator. So 6.4 divided by sine 23 gives us 16.4. Oops. So 16, I did it again. 16.4 is our final answer for that one. Okay. And then the bottom one, let's just look at it quickly. Start with our angle. In this case, our opposite we don't know, so we'd use adjacent over hypotenuse. So we'd have cosine in this case. You'd have cosine 70 equals 1.5 divided by x. And just like the one we did before, let's just flip-flop them so it makes it easier to figure out. So we'll move our x to the top. Bring our cosine to the bottom, so we'd have 1.5 divided by cosine of 70. So 1.5 divided by cosine 70 gives us an answer of 4.4. And that's it. So the first two, we did a sine and a cosine where the x was on the top of the fraction. The last two, we did a sine and a cosine where the x is on the bottom. You can see it's the same setup we did for tangent, just a different formula. Okay. This last page, we'll just look at a couple of these ones. They work the same again, except we're looking for an angle. So it's just like we did with the tangent. Start with your angles. In this case, angle A. We have our opposite side is 14. And in this case, our 25 is our hypotenuse. That never changes. And adjacent would be this one, which we don't know. So that's it. We just basically solve for that question. So we'd have sine of A equals our opposite 14 divided by hypotenuse, which is 25. And remember with these ones we just want to do second sine, right? We want to get rid of that sine. So you'd go sine shift or second sine brackets 14 divided by 25. And that gives us an angle of 34 degrees. Okay. And then let's just do a couple more to make sure we got it. So for this one, let's look at angle here. So our opposite, we don't know, so it's not going to be opposite, so that means it has to be cosine. So our cosine is adjacent, 2.1, over hypotenuse. So it works the same way. So we have cosine of the angle would be 2.1 over 4.2. So to solve it for the angle, we want to get rid of that cosine. So second cosine, brackets 2.1 divided by 4.2. And that gives us an angle of 60 degrees. Okay? And we'll stop there. The letters C and D are the same thing, just using cosine and sine again. So that's it. So that's it for our review. Just kind of the key things to remember is when you're labeling your triangle, just remember depending on wherever the angle is, doesn't matter how the triangle is drawn. If I'm talking about this angle over here, our opposite side is always the one straight across. Our adjacent is always the one beside the angle. And our hypotenuse is always the one across from our 90. And if our angle was up in the other corner, then our opposite and adjacent just sort of flip-flop spots. So be careful how you label your triangles, and then after that you just remember to use the three formulas. So if our question has opposite and adjacent, we use tangent. If our question is opposite and hypotenuse, we use sine. And if our question is adjacent and hypotenuse, then we use cosine. So there's our three formulas for any particular right angle triangle. And you might have learned from last year a good way to sort of remember these formulas is to use the acronym, or the way of saying it is SOHCAHTOA. And all SOHCAHTOA is just a way to help you remember the formulas. So you can see the SO is SOH, so that's sine equals opposite over hypotenuse. So we're just using the letters there, so SOH. Ka is for cosine, so cosine equals adjacent over hypotenuse, and then TOA is tangent over equals opposite over adjacent. So it kind of helps you remember the order of them. So if you want to use it, go ahead. If not, I'll be giving you these formulas on a formula sheet, so you'll never have to memorize them anyway, but it sometimes helps. So that's it for today. We'll start looking at some more complicated triangles tomorrow. See you.